Welcome GibbsCAM users. Today's classes will be class number 2. We already had class number 1 which was just prerequisites for whether you're using milling or turning, same thing. But this is class number 2, which will be doing a 3-axis vertical mill, and we'll be drawing this part from scratch using geometry. I know many of you now work with solid models, which is much easier, and maybe you do that already, but you still need to know the basics of how to draw and using geometry, because there will be times with a solid model that you'll have to pull geometry off and maybe modify it or add some things to it. So that's what this class is going to begin, and we'll be doing it from beginning to end. And so before we get started, let me show you the print. This is the print that we're going to be drawing from scratch. This is, you can see, kind of an isometric view of the finished part that we want to draw. And this will be available in the under the More section in the description there. You can download this blueprint as well as the vise we're going to be drawing and the tool list. And so let me just get this out of the way. So the first thing you want to do after you have your blank Gibbs screen open is go to File and New, and of course find a place on your hard drive wherever you want to save this. Do not save it on a USB stick and work on a USB stick or CD or anything like that. It needs to be on like a hard drive or something that has more disk space and can save while you're working on it. So just keep that in mind. So next, give it a name, whatever name you'd like to do. I'm just going to call this 3-axis mill geometry. Then save it. Now it's going to open up a blank Gibbs screen, and if the last screen you used was a lathe, that's what it's going to bring up. In this case, the last screen I used was mill, so you don't need to worry about that. If your screen looks different than mine, that's okay. So next you want to go to Document Control, and you want to choose the machine that we're going to be programming today. In this case, a 3-axis vertical mill. You can see there's a drop-down menu. I have more menus than you probably do, but you can choose 4-axis vertical, 5-axis, 4-axis, 3-axis horizontal, etc. But we're working on a 3-axis vertical mill. So the next thing you want to do is you want to go to the material family and choose what material this is. I'm going to just choose aluminum alloys wrought. This is your standard like 6061 and that kind of stuff. So that'll be good. We're programming in inches. And this was just the blank screen I had from previous part I had, so that's okay. Let's just leave that there for right now. This is a Cat 40 machine, and this is the clearance value. Now keep in mind the clearance value, if you were to bring the tip of the tool down to this clearance value and you were to move the machine in X and Y, would it hit a clamp? Would it hit any kind of material? This is what you need to keep in mind when you have your clearance, because this is where the tool is going to wrap it to from home before it starts cutting. So normally I like to keep it at say 1/4 inch or 100 thou, so that's totally up to you what you'd like to do. So if we look at our print, let's bring our print back. And of course here is our print. As you can see, the stock size is 4 3/4 by 4 3/4, and this is the finished part, 1 inch. But I have the material listed here as 4 3/4 by 4 3/4 by 1 1/4, because we have to have something to hold on below that so we can machine the whole outside of that before we cut the bottom off, maybe face the bottom off. So a couple things here to note. Note that all the dimensions come from this point right here, this center point here. You can see all the dimensions from this whole part come from this particular origin here. Now this isn't where I would want to set my tools up and my X and Y location in my CNC machine. This is just how the drawing is. So you don't want to start off putting your origin like over in the left hand corner. Maybe that's where you want to touch your edge finder off or your probe, because if you do that, then you're going to have to back calculate all the dimensions here. And to do that, that's a lot more work to do. So always start out the part. If you get a blueprint, always put your origin where all the dimensions come from, because in Gibbs you can be all done with your part and then just decide you want to move the origin over to here, maybe the middle, over to the right, front, wherever you'd like to put the origin. You can always do that in Gibbs at any time you would like, even if you're all done, ready to post code. You can move the origin where you would like. It's very easy to do. Also in this print, I made it a little bit easier to set up your stock size in that in Gibbs by telling you from the origin how far it is to the stock, 1 3/4, and the same thing with the opposite side here. So if we follow the print, if I put the X max, this means how far is it from the origin to the right side of the part, the X max. And if we look at your blueprint, you'll see it's 1 3/4. And of course, our overall X dimension is 4 3/4 stock. So 4 3/4 minus 1 3/4 is minus 3 inches. So this means the left side of the material is 3 inches from the origin. Okay, now the same thing with the Y maximum here. If you look at the blueprint, you'll see that's 2 inches. So 4 3/4, it's 4 3/4 square. So 4 3/4 minus 2 inches. So if you want, you could do the math as well. So 4 3/4 minus 2. So you can do math in any one of these windows in Gibbs. Of course, this needs to be a minus. And of course, the stock size, as far as the Z, we want to face some off with a face mill. So I'm going to put in 20 thou there because I want to face off 20 thou. So if our material is 1 3/4, or sorry, 1 1/4 inches thick, so I take 1 1/4 and minus 20 thou, that means it's Z minus 1.230. Okay, so that should put our origin right where we want it, where all the dimensions come from. The rest of this we'll just leave alone. So now you can see our stock size here. Let me roll the middle mouse button and unzoom it a little bit. So this is our origin, X0, Y0, Z on the top. If I go to isometric view, you'll see the Z is on the top there. Rotate it around, you can see everything looks good there. So you can turn on the grid or turn it off, it's up to you. If you kind of want to hide it, you can keep clicking this button till you see everything go away except for the origin marker, which is kind of how I like to run it. So the first thing I always do, especially with this print, is I'll start putting points in specific locations where maybe the holes are. That's probably the easiest thing to do. So I'm going to bring up my geometry palette. And of course we want to put on points and put them in according to X, Y, and Z. So now we're in the X, Y, Z coordinate system, and you can see there's either 2 points or 1 point. And what this means is if you click 1 point, it's going to go back to the main menu just like that. It'll go back to this main menu. If you click on the double points, it'll stay in this menu, and then you can keep typing in values. So the first point I want to put in is X0, Y0, Z0, and I'll click the double points here. And as you can see, it puts a point right in the middle of the screen there. So the next point I want to do, if I'm looking at my print, I'm going to just go X and Y. I'm going to put in 1.625. Now you don't have to keep bringing your mouse up there once you click the double points. You can just type in the values and press enter if you'd like, and you can see it puts a point in there. I'm going to stay at X0 again and go minus 1.410 will be the next one. And the next one would be minus 2.340 if you're following along on your print. So that has those pretty much done in line right there. So maybe the next point I want to put in will be the, we'll put in the X minus 1.910. And that'll be 0.880 from our origin. That'll be the kind of the hole on the left side there. The next one is going to be minus 2.2. And Y is going to be minus 1.870. Again, press enter. So for right now, this is all the information we have for X, Y coordinates for each hole in this part. There is no other holes or points in here that we can put in that has an X, Y coordinate system. So let's just go back to the main menu just by clicking on this button here. So the next thing I usually do is start to draw circles, maybe for the holes, maybe the part, or both. So in this case, I'm going to click on the circle command. You can see you have a lot of choices here. Radius, center point, a lot of different choices there. Just by hovering over there, you can use those. But I want to go from point and a radius. So I'm going to click on this button here. And again, it asks for CP, which means center point. If you click on here, you can enter that center point, but we already have the points on our screen. So I'm going to click on the first point there. And if you look at the print, these are 3/16 holes. So I'm going to type in 0.1875. And notice it's asking for a radius value. So I'll just put divide by 2. And I'll click the double circles because I want to stay in that menu. Now while we're at it, let's draw the rest of the circles that we can. So I'm going to click on here. The value is still in there, so just click on the double circles, or you can press enter. Either one, press enter. And over here, press enter. So now we have the small holes drawn in here. So let's draw some of the bigger holes. Again, let's start out with this one here. And the outside, you can see on the blueprint, it says 0.190 is all outside fillets. Radiuses, fillets, the same thing. So we'll put in 0.190. And again, we'll do the double circles there, one there. And you can, like I say, use the enter key, or you can use the space bar, either one. Put one there and one there. Okay, now we have most of the holes drawn, not all of them, but this is all the holes we have using XYZ. So now let's put in some of the bigger circles, like this one here. And the radius, if you look on your print, you'll see it's 1.34. The next one is 1.466. Now let's put some circles down from this point. As you can see, we have 0.770 and 0.896. So 2 circles down there. So those are all the circles we can draw at this point. So click this menu down here. That'll take you back to the main menu. First thing I'm going to do is draw big circle again. And if you don't necessarily see the command on here, Gibbs already knows what you want to do. So I'm not going to choose any command here, because what I want to do is I want to draw a circle that is tangent to this circle and tangent to this circle. And you won't see a menu for that. So just click on this circle and click on this circle. You'll see the menu will change, and then it asks you for a radius on there. And the radius, of course, is 1/2 inch. And it's going to give you, in this case, 1, 2, 3, 4 choices there. You want to pick this one right here and click OK. As you can see, it draws a circle tangent to this circle and this circle. Now let's draw a few lines where we're at it here. So the next thing we're going to draw is some lines. So I'm going to pick the line command, and I'm going to pick the third one over here that says angle and tangent to a circle. So I'm going to pick this circle down here. And if you look at your print, you'll see it's 10 degrees off of 90. So we're going to say 100 degrees. And it's going to give you 2 choices. Of course, we want to pick the outside one. Click OK. And another one we're going to draw is off of this circle. I should have clicked the double circles, which I didn't, but that's okay. You can just come back to this as well. So you can, if I go back, pick line, tangent to a circle, pick the circle, and you can see this is going to be 45 degrees. So I'm going to pick the double lines again. It'll stay in that menu. Pick that. Now we have that line there. Now we need to have another one across here. I'm going to pick this one again. And this is just a straight line, so it's going to be at 0 degrees. Pick that one. Okay, now we have a few other choices here as well on these ears that come off of here. So I'm going to pick this one here. And you can see the blueprint, it's 75 degrees included angle, or 37.5 degrees off of 90. So I'm just going to do a little bit of math here. So I'm going to type in 90 plus 37.5. I'll click the double lines to stay in there, and you can see it gives you 2 choices there. We want this one here, and we're going to do the same thing down here. And there we have our 2 lines there. Now we need to do the opposite side, so I'm going to click on this circle again. This time I'm going to type in 90 minus 37.5. And again, click on the double lines. And down here, double lines. And now we have basically our 2 ears drawn here. Okay, now while I have that there, I need to draw the ear over on the right hand side. And this is the easier way to do it rather than trying to calculate all the angles off this one, is just click what you want to copy, in this case the point, hold down Control key and double click this line. You can see it'll highlight everything that's connected to it. Go over to Modify, and we just don't want to rotate it, we want to duplicate it and rotate it. So it's going to ask you 2D rotate. Where's the 0 point of your rotation? Well, it's right here, and that is, of course, X0, Y0. You can always click the Alt key or the Alt Shift key and click a point there, and it'll input the values there for you. So if you look at your print, you'll see it's 30 degrees off of 0, so that means it's 90 degrees clockwise, 60 degrees clockwise. So I'll do that. And I just want to do it one time, so I'll click on Do It. And now you can see that ear is over here in the correct spot over here. Now a couple other things we need to do. We'll probably draw the outside first, and then we'll start drawing the inside. Now this is where we get into connecting features up in Gibbs. And I'll also include a little cheat sheet on that you can download on how to use the connecting to connect things up a lot faster way than normal. So I'm going to click on the point command, and do not choose any other menu here. Gibbs will know what you want to do as soon as you click on two features, in this case this circle and this line. And you can see the menu automatically changed. Again, we want to click on the double points because I want to stay in this menu, so click here. You can see since this line intersects this circle in two places, Gibbs is asking you which one do you want to keep. I'm going to click on this one and click OK, and you can see it's up here. Now what Gibbs did, it trimmed this circle automatically. So what we're going to do while we're still in this command to connect, we're going to click on this circle, and you can do the shortcut Control D, or you can go up to here and click on Duplicate. So that's just this menu right here, Duplicate. And you can see it duplicated that circle again. And of course, it's just a circle. It's not connected to anything. But while we're here, it's already highlighted, so I'm going to click on this line right here. And I'm just going to click either the Enter key or the Space Bar key. And again, this intersects this circle in two places. Pick the one you want to keep, that one. And you can press Space Bar or Enter again. Now we're going to continue on. So think of the end mill as coming down here, going over the ear. Now where it needs to go is over here, then up this ear. So I'm going to connect it right here and here. And again, you can see it trimmed this circle here. So we need to duplicate it one last time. So you can do Control D if you want, shortcut. You can see it's already highlighted, so I want to connect it to here. Okay, now it didn't trim it because it needs another line through here before it can trim that circle. So let's get out of this menu. And obviously I want to draw a line that's tangent to this circle and this circle. So I'm going to pick the line command, but no other menu. Just click this circle, click this circle. Gibbs will know what you want to do. We just want to do it one time. Gives you two choices. We just want this choice here. And now you can see it trimmed the circle again all the way down to here. Now again, we need to go back to connecting again. So let's connect again, here to here, and double points. We want to save this one right here. And again, you can see it trimmed this circle. So while we're at it, just click here and Control D. And again, connect there, and there to there. And let's just follow the rest of this around, which is basically just these two right here. And now we have our outside shape fully constructed, except for the fillets. Now we're going to wait a little bit to draw the fillets in here. Let's finish the inside here and finish the pocket over on this side. So if we look at this one, you can see there's a line that's tangent from this circle to this circle. So I'm going to pick the line command, and again, no menu. Pick that circle, pick that circle. We just want to do it, well, we want to do it twice, so we're going to stay in this menu, so we'll click the double ones there. And I want to save just this one, and you can see it's automatically connected there. But on this one, it's not a line tangent from here to here. It's actually tangent to this circle here. Now, even though you don't see the circle go clear around here in Gibbs, invisibly it is still back there. So if we pick a line that we want to go from this circle to this circle, and we'll just do it one time, you can see it gives you 4 choices there. Of course, we want this choice right here. And of course, it's not going to trim it because it was this circle is already connected. So we just want to connect it from there. And you can do it this way as well. You can see the cheat sheet on how to do it. Hold Control key down, click the 2 items you want to connect. Then while your mouse is there, just right click and say connect. And of course, this line intersects this circle 2 places. We want to keep this one here. And there we have that circle drawn on the right side. Now we need to fill it in here, but we'll wait to finish this side before we do that. So if you look at the print, I have 2 construction lines here. So I'm going to pick this line command and line and an angle. So I'm going to pick this point down here. You can see the first one is 10 degrees off of 90. So that'll be 80 degrees. I'm going to pick the double lines. Okay, that's a construction line. And again, I'm going to click it again. And you'll see that's another one that's 10 degrees off of 180. So that would be 170. And there we have that line as well. Now we have our 2 construction lines. Now I can finish this pocket over on the left side here. So I'm just going to do line and this time parallel lines. So click line and parallel. And if you look at your print, let's go over here. Let's click this one first. And the first description or the first dimension is 2 inches. Click on here, and of course it draws a line parallel to both sides. So I'm going to click this one here, click OK. So that is 2 inches. The next one is from here, and the print shows it 5/8 or 625. Do that one, pick the bottom one. And then again from here we go 1.050 to get the top line. Okay, so far so good. Now the rest of this is 1/4 inch parallel lines off of these 2 lines. So we'll do here first, type in 1/4 inch. And from there and over from this one as well. Okay, so that's good. And now we need to add a 1/4 inch to this circle here to draw this one. Now you can see Gibbs already has a point there. If it didn't, you could just say find the center of a circle and click it and it would put it back there, but we already have a point there from when we drew the circle. So I'm going to draw a circle from a center point, and there's our center point, and this will be 0.75. So now we have almost everything. I forgot one line that needs to be 1/4 inch off of there, so I'll just go back and go one last one. Okay, now to make things a little bit simpler, let's get rid of our construction lines because that confuses a lot of people when they go to connect. So let's just click on this construction line here and delete it, and this one here and delete it. So now we can connect everything up through here. So the fastest way, again, click the point command, don't choose any menu, and just start connecting. So let's just start. Now you usually want to connect as maybe the tool going around it, either clockwise or counterclockwise. Don't connect up here, then connect down here and over here, or you're going to end up with a mess. So just pick a logical place. So let's just start from here to here and pick the double points so you stay in this menu. Let's go from here to here. Press spacebar or enter key. Here to here, here to here, here to here, here to here. And this, of course, intersects 2 places. Which one you want to keep? This one. And here to here. Last one intersects 2 places. We want this one here. Okay. Now we have our pocket drawn on the right side and the left side. Now we need to just start putting in our fillets. And one last hole here, but let's put in our fillets right now. So to do fillets, you can see this is our chamfer fillet command. I don't know why they don't add notes and say fillet, but it just says chamfer. But this does do fillets and chamfers. So if you just want to do one, like in the case here, I could just click on that point. This becomes active. I can say this is a fillet here, and we want to put 1/4 inch there. And we want to do it, of course, more than one time. So you can see it puts the fillet in there. Now the next one, I want to do a fillet all the way around the outside here. So another way to do it, instead of clicking all these points here to go around here, just double click the shape. It highlights everything that's connected together. And again, this says, the print says 0.190. So I need to do 0.190. And you can see now we have fillets everywhere on the outside of that part, 190. Okay, so the inside here, if you look at the print, you'll see it's typical 1/4 inch. So I'm just going to double click it again, type in 0.250, and just do it one time. That's the last fillets we need. So now we have the pocket on the right side done, pocket on the left side done. Now we need a couple more holes drawn in here. So let's do this one first. And if you look at your print, it is exactly 0 degrees from this one. So I'm going to draw a line at an angle from here at 0 degrees. So there's our line there. And then it is actually 1/8 of an inch from these two parallel lines. So I'm going to draw another line parallel. You can pick either line you want, doesn't matter. And we want to put 1/8 of an inch in there. And pick this one right here. So now we have our two lines and they're crossing. So let's just connect it there. Holding Control, right click, connect. Now you can delete those construction lines. And now you have a point that you can put a circle in there. And that's like 0.1875 divided by 2, just one circle there. That's all you need. Now we have a circle over here, and you can see on the print it doesn't give you an XY location. So let's just zoom this up by using your mouse and making a window around the section. And if you look at the print, you'll see there's a dashed line, a dotted line, and that means it's tangent to this line, this little short line, and this one here. So let's pick the circle command so we can draw a circle in there. So let's pick the circle command, and there is no menu for it that shows tangent to 3 lines, but just pick your lines. You don't have to hold any keys down, just press this line. I want it to be tangent to this line and tangent to this line. It's not going to ask you for a radius because it knows it has to be tangent to those 3 places, so that controls the diameter. So just do it one time. It's going to give you a bunch of choices there. Well, 4 choices anyway. You want to pick, of course, this one here. And now we have our center point. So now you can delete this construction circle, but now you have your center point. So pick circle, center point, and this is a 3/8 through. So 0.375 divided by 2, and there's our circle over there. So we just have a few points in here that we can leave, or we can get rid of them. Maybe I'll just click on those, holding Control down, and delete those. So now we have our part fully drawn, ready to go to do start our cam. So the other half of this video is going to be how to put toolpaths to the geometry we drew. So the first thing I probably want to do is move the origin where I'm going to touch off with my probe or my edge finder, and I think I want to put it at the top left corner. So we know our stock size is, let me just open up document control, is 4 3/4 by 4 3/4. And let me move this up here, this over here. So I want to move the origin over to here. So the easy way to do that is just go to Modify, Move Part Origin, and we'll just zero these out. But if I look at my stock size over here, I can see the X's from the center of my origin over to the left side right now is -3 inches. So I'm going to say move the origin -3 inches. Going to go down to the Y, and the Y is 2 inches. So it's 2 inches from the origin up to this corner. So I'm going to put 2 inches in there. I'm going to leave Z alone and click on Do It. Now this is an incremental command, so if you do it again, it's going to move again. So don't keep clicking on that. But now you can see the origin is the top left corner, and you'll notice that Gibbs has updated the stock size automatically. So it knows that our origin is the top left corner. You can see 0, 0, and this is our stock size. So now we can start putting tools to it. And like I said before, you could move this origin if you're even all done with toolpath, ready to post. You can move the origin there, but we're going to put it right up here, right off the bat, so we don't forget. Now let's do a couple measurements here, even though we have it on our print, but just to see what size end mills and everything we need to use. So let's just go to our dimension palette. And I want to know what this fillet radius is in here, even though I can look on the print, but I'm just going to click on that anyway. So that's basically 190 or 3/16 there. We'll just round it off there. And of course we know the holes and everything else on here. And let's just do radius in here just to check that. Again, and over to here, we'll check that as well. So 1/4 inch there. So that means when I finish this, I can use as big end mill as I'd like to rough this out, but when I finish it, it has to be like a 3/8 diameter end mill if I want to meet the specs on here. And the end mill can't be larger than 1/2 inch if I want to meet the specs inside these two pockets. So I'm going to load up the tools. Now you have the tool list available that you can download, and we'll go through this, or you could just individually put them in here. So to create a tool, since this is just a beginning class, create a tool, you just double click an empty tile and it'll automatically open up this window here. And of course you can move these down to wherever you'd like if you need to change that, but let's just delete that one. So I'm going to bring in the tool list that will populate our tools already, and like I say, it's downloadable, so you can do that as well. So in order to do that, just right click anywhere on this list and go to Load Tools and Browse. Now you can set a folder, so if you have a tool list for each different machine you have in your shop, you can set a folder, just say tools for a Haas machine, a Makino machine, a DMG machine, whatever you would like. You can just set a folder and have the different tools in there, so you don't have to create tools all the time, especially if you're running a horizontal. Most of those tools are somewhat set. But let's just go to Browse for right now, and I have the tool list in here. This is what you can download as well, so just click on that and click on Open. And you're going to have your tool list right there. So let's go through each one of these tools just to so you know if you want to create them by hand, that's fine. So first tool, let's double click it. It's going to be a face mill. And I just put this, the shaft size in here. That's not really that important, really. What matters is the diameter here, the angle, and the small diameter here, what you're actually going to be cutting with here. And you can see there's a preview of it down here. So I created the tool, went to click on Mill, and you have to make sure you put in, if you're going to use speeds and feeds, you want to make sure you put in the right amount of flutes in there. Length out of holder, I just have 3/4 of an inch. That's not really important, as long as you visually see it looks like it's supposed to. And tool length offset, since this is in pocket number 1, make sure this always matches. So tool length will be 1, cutter radius comp will also be 1. So make sure these always match whatever pockets over here. Okay, you don't need to use tool ID, anything else on here at this point in time. And we want the spindle direction to go forward. That's the normal rotation, so that's like an M3 in there. Then of course give it the tool material here. This is carbide insert coated. You can see the drop down menu there. And I usually put a comment in here that will help, because this will be posted out in the code so you can see what tool you should be using. So the next tool is going to be a 1/2 inch rough end mill, no corner radius, 2-inch flutes, 4-inch overall, and sticking out of the holder 2.5 inches. And of course you'll notice the tool length offset automatically incremented to 2 and 2. And this is just in a holder. You can see you can choose whatever holder you have, mill, bore, tap, whatever you'd like there. And again, I gave it a name. Tool number 3, 3/8 end mill. This is also going to be a rough end mill. Same amount of flutes, 3, a little bit different on the holder stick out and the name. Let's go through this one. This is going to be our finish end mill. So I have FEM for finish end mill. This is the 5 flute, and again put in the values there, if it's carbide, if it's high-speed steel, cobalt, whatever. Next is going to be a spot drill, 1/2 inch, 4 flutes. Now this is a combo spot and chamfer tool. You can use this type of spot drill to not only spot drill but also use it to chamfer around the outside. Next tool is a 0.187 drill, 3/16 drill. Notice you can use the diameter, you can use letters or number drills. Okay, so I just have a 3/16 diameter, and this should be actually 120. Okay, you can put in whatever angle you want in there. It should match your tool, of course. Last tool, 3/8 end mill, 3/8 drill, and again 120, and 2 flutes, so everything else there looks pretty good there. So now we have our tool list. Let's start putting some toolpath to it. I'm going to turn off dimensions by just doing that. So the first thing I want to do is face this off. Remember, we have 20 thou to face off here. So I'm just going to create one process. This is your process list. We're not going to do multi-process on here. That's in a more advanced class. We're just going to start out with one tile at a time. So in order to create a process, just double click there. And we just want to use roughing. It's under the roughing command, the face command, and the tool we want to use. It automatically brings up this window here, and you might see it says offset, offset with cleanup, zigzag. So if it happens to be in offset there, make sure you go down and choose face milling. Now again, we set our rapid plane at 1/4 inch, so that's why we have this here and here. And balloons work on here, so if you get confused, just turn on balloons, Control B, and it'll give you a definition of how to use this. Now remember, this is the surface we're cutting. We have our Z0 on our part 20 thou below the rough stock, so that's why we have approximately 20 thou to face off there, and we want to face it to 0. And of course, you click on your speed, RPM, and contour. It'll match your aluminum that we're cutting. Now, if you don't like these feeds and speeds, you can always go back to material and make the changes in here to update the database, and then you can use that database from now on, and it'll have the correct feeds and speeds for you. Not every speed and feed is the same for every material and every type of machine. Cut width, I put 1.25 inches there. You can adjust that how you'd like. And do you want to cut the stock or a shape? Now, if you click on shape, it's going to require that you actually select a shape, but we want to cut the whole stock, so that's why I have this on stock. Now you can decide what corner you want to start with and what direction you want to go first. You may want to think about where it's throwing the chips. Normally you don't want to go from the back forward as it's going to throw the chips at the operator. You kind of want to go maybe sideways or front to back, so that's totally up to you how you want to do that. And what's your first cut, and what do you want to do? Spiral in, back and forth. I just have back and forth in. Everything there looks good. Clearance, I have coolant on, round corners on, so let's just click on do it. And you'll see our first toolpath here. Now let's just render this. So we'll render this as we go along on each step. You can wait till the very end to render, but just we'll just go right off the bat to render. So let's go op sim. And you can change this op sim by right clicking up here, going down to settings, change to accurate, fast, or custom. I usually like accurate, so I'm going to change that to accurate and click apply. All right, and we're going to have it show the tool holder. And this is our speed bar, of course. I'm going to start right at the very first notch there. We'll rewind it and click on play. So there's our tool. You can see it going on. And there we're finished with facing that off. So it looks good. So let's close this. Now if you want to get rid of the toolpath here, you just want to see it, you can click an empty tile here. And that's usually what I do, just select an empty tile there, and you can see that disappears. Now if we're going to use the same process, we can leave it in here, but I'm not. I want to do a roughing process with volume mill, so I'm going to click on clear and double click here and use the volume mill process along with the 1/2 inch rough end mill. And it's going to bring up the volume mill. Now the volume mill is really nice, and it's high-speed machining, and it's very accurate. It works very well. You just need to input the parameters for what you want to do. So let's click on this button here that says Technology Expert and fill in the blank. So this is a low silicon aluminum, and that's your Brunel there, which is about the same for most aluminum. What's the machine taper? It's going to be, of course, 40 taper. And what's the maximum RPM of your machine? It's not saying you want to go this fast. It's just asking you how fast can your RPM go on your machine, and what's the maximum feed rate you can go. So I put in 15 thou and 1,000 there. Now it asks you here, how are you holding this? Well, we're going to be holding it with, say, a Kurt Vise, and we're holding on about 150 thou, or actually 230 thou. So we're holding it pretty good, but maybe these are smooth jaws, so I don't know if we want to go clear up to rigid. I might just stay down here a little bit. And how aggressive do you want to get with the cut? Usually I start around here before, and if I'm doing a lot of different parts, I can see how this works and everything cuts fine, and then you can always move this up and repost the toolpath. So what kind of holder are you using? Well, in volume mill, you want to use an ER collet because it will pull out the end mill out within 10 seconds. So you don't want to do that. You can use an end mill holder, TG collet, hydraulic chuck, milling chuck, or shrink fit. So we're just going to use a hydraulic chuck. It's pretty popular. And what's the tool? Uncoated or coated. That'll change the feeds and speeds for you. So let's just click on check all. If we had, usually it's blank like this, so let's do check all, and then apply checked, and you can do apply all as well. So there's our RPM. Looks like it is going to use 15,000 RPM, and this is the feed rate, and this is the recommended width. So if you look at those numbers, you can see that's actually pretty aggressive, but it works really good with the end mills and with a high-speed machining with volume mill. So we want to leave a little stock. Volume mill is just a roughing process, not a finishing. It's just a roughing. So we want to leave a little XY stock. And we also want to leave, well, we're doing the outside first, so I'm going to leave basically 0 stock because we don't care on the depth. If we need to come back and finish on the depth, that doesn't really matter. And you can leave the rest of these default. Repositioning parameters, 10 thou off the floor. That means when it gets done making a cut, it'll move up 10 thousandths off the floor, and then high feed rate over, and then cut again. So you can see the high feed rate was, I'm going to put 1,000 in there. That's not what it's cutting. That's when it's repositioning to cut again. We're going to use the stock, and we're quarter inch, and this is how much stock we have. Actually, we faced that off, so that's going to be 0. And if you look at your print, you'll see it needs to be minus, it's 1 inch to the bottom of the part, which is how thick the part needs to be. But I'm going to go a little bit past that, so I'm going to say minus 1.050. And we're probably going to do that in a few cuts, so I'll just type in 0.5, and it'll say 3 passes. I probably want to do it in 2 passes, so maybe I'm going to say 0.6, and it'll round it off to 2 equal passes there. I don't care about it. Don't need a plunge because we're starting on the outside. I want a climb mill, cooling on. Everything there looks pretty good. Now before we do that, I need to make a wall around here. What we call is an air wall. This is just stock. So if I turn off stock, sorry, right there, you'll see it disappear. So that's not the actual geometry there. I need to draw geometry around the outside of this so we can use volume mill and make it an air wall. So I'm going to go over to geometry and click on this create a box. Now we know our stock size is 4 3/4 by 4 3/4. If you look at the print, you'll see that's the size. And what size, or where do you want the origin to be? If we look at our part, remember we have the origin at the top left corner, so that's why I'm going to click on that corner. You can see you can choose any one you want. And this start position is 0x and 0y. And click on do it, and now you'll see you have geometry around there. Now, if I was to machine this now, the end mill would stay within these boundaries here, so it would jump all over, and it would leave a lot of stock because it knows it can't violate this wall. Well, we're going to change that into an air wall, and to do that, let's close this. Just double-click the shape, go to Modify, down to Toggle Wall Air. So we're toggling the wall to an air, and if you click in space, you'll see it turns red. That's telling Gibbs you can go outside this wall now. That's okay. So we already have our process done, ready to go. So I'm going to just hold down the control key, click the outside box, and you don't have to double click the shape. You don't have to do that. You can just click on one side and one side on here. It doesn't really matter since it's a closed shape. And click on do it. And you'll see there's our toolpath for cutting the outside. Let's run the rendering on this. We'll speed it up. And you can see I set it to just climb mill only. And when you see it reposition, it does not use any G0s in the code. It's all G1s, but it's a high feed rate. So it's almost as fast as a rapid, but it's a G1 move, so it knows exactly where it's moving. And the second cut, remember we're doing it in 2 cuts. Speed that up again. Okay, now we have the outside roughed out. Let's go to our next process. And again, if you don't want to see this toolpath here, as it kind of gets annoying if you already have it up and you're trying to create another toolpath, just click an empty tile there and you'll see that'll go away. So now we want to rough out the ID before we do any finishing because it's going to stress relieve. So we're still going to use volume mill, but we're not going to use tool number 2. Actually, we're going to use tool number 2 on this side, sorry. So we'll keep that tool in there. We're just going to open up the process just by double clicking on it and change this. We know by looking at the print the depth of that is 3/4, so I'm going to say minus 0.75 is our total depth. And it's going to do it in 2 steps unless we make this desired step larger, but 2 steps will be just fine using that 1/2" end mill. Everything there looks good, the same as before, but this time we need to leave a little stock. I'm going to say 10 thou on the bottom as well. Everything there looks good. Click on one side of the pocket, doesn't matter which side, click on do it. You will notice I didn't get a toolpath there. So the reason why is it needs to go into the material somehow, and it just can't plunge with the end mill, otherwise you're going to snap it. So that's why volume mill did not give us a toolpath. So let's just open this back up. And this type, plunge type, I see I have do not plunge on there. This time we're going to do a helix. And 2%, 2 degree angle, and all this looks pretty good there. So let's do, since I already have this done, we can either delete it and click do it, or since it's already highlighted yellow, let's just click on redo. And then you'll see we have a toolpath there. So let's run that simulation. And there's our helix down in there. We could change the helix to start a little bit closer, but since this is just our beginning part, we'll leave it how it is. There's our first step. Now it's going to helix again to do our second step. And there we're finished with that. Now we need to change tools. We're still going to use volume mill, but we need to do this cavity over here. And a 1/2" is a little big to get in between here when we're doing the high-speed machining on here, and want to make sure we have enough evacuation on the chips. So we're going to change tools. So I don't need to clear this out. We're using volume mill, so just take this tool, tool number 3. This is a rough end mill. Drag it, put it on top of there, and you'll notice that changes from 2 to 3. So tool number 3. Again, I'm going to go down to 3/4 inch. And we'll do this in, this is a 3/8. We'll do this in 2 passes. That's about 3/8 deep each time. All that looks pretty good. Okay. Click on this side here and click on do it, which will put it below this one. So make sure you don't click redo, otherwise it'll override what's this already. So click do it. And now you'll see we have the toolpath over there. So let's run the rendering on that. And you can see that's done now. So now we've roughed the outside and the inside. Now we need to do some finishing here. So you don't want to use volume mill really for finishing because it's just made for roughing. So I'm going to click on this clear button and put in just a standard Gibbs roughing toolpath. This time with the 3/8 finish end mill. And we're doing a standard offset there. We're going down to 3/4 inch, but I think I'll wrap it a little bit closer so it doesn't feed all the way down there. So I'm going to put minus 0.740. So it's going to wrap it down in there to minus 740. That might be a little close because I think we left 10 thou on there. So let's go minus 0.7. It'll be safe 720. So it's going to wrap it in down to that point. Let's give it a little bit of arc in, arc off. You can change these to whatever you would like. We're not going to leave any pocket stock, everything. Cut width 0.187, that'll be just fine. Round corners, cutter radius comp on, climb, coolant on, everything there looks pretty good. So we're going to go to top view. And we're going to do the one on the right first. So just click on this. And actually we can do both of them because it's a roughing process, so that lets us choose both pockets at the same time. Click on do it. Now we have our toolpath there for the finish. Let's run our simulation. Let's turn colors on so we can see each one a little bit better. I already have some colors turned on, but let me just show you this. So this is I want to do it by tool number. You can see Gibbs color, op number, or tool number. We want to do it by tool number. And you can see this is op 1. The colors there, you can always change these colors to whatever you'd like. You don't have to use the ones that are here already. But let's run the simulation on the finish there. So there's it finished. And there it's finished on the outside. Now we need to do the inside. So it's easy to make changes there if you made a mistake. I have a roughing process in there. So just right click and go to change process to a contour. So now we've changed to a contour. Let's check our numbers. Minus 0.720 is good. 1.03 is good. Entry and exit. Don't want to force it into stock, so we'll zero that out. Everything there looks pretty good. We'll update our RPM and feed rate there. And we'll choose the side we want to cut on. So I want to cut on this side to start. I want to cut on the outside of that line, and I want to climb mill, so this will be this direction. Now I don't know if I want to arc in and arc off this same point. It'll leave a little witness mark. So I'm going to drag this white marker off the part. This is our starting point where the tool is going to plunge down and start cutting. And this is where it wants to end on this line here. So I'm going to take that one, drag it off a little bit on there. If everything looks good, click on do it. If you made a mistake, you can go back and make any changes and click redo, but that looks pretty good there so far. Okay, so let's go to simulation. Slow this down a little bit. And there's our finish pass. Now if you want to double check things, you can always turn on show geometry, and you can see it matches our geometry perfectly. This red you're seeing is from our roughing. So it matches our geometry perfect. You can turn that back off if you want. So the next thing I probably want to do is chamfer the inside cavities and the outside, and then use that same tool to spot drill everything. So let me turn off rendering. And we're going to use a contour, this time with tool number 5. So just take tool number 5, drag it down on top of there. So here I have my process open. I don't want to wrap it down into the part. I'm going to stay at 1/4 inch like we said before. Top of our material is 0 already, but I want to go down a little bit on the spot drill. Let me open this up. So it's a 1/2 inch and 90 degrees, so that means I only have a 1/4 inch to play with here. I want to get about halfway up this end mill, or sorry, the spot drill. So I'm going to say minus 150. Probably be good. Entry and exit's fine, but this time I want to force it into the part. If you look at your blueprint, let me drag it over here. You can see it says 20 thou chamfer on all edges and holes. Move that back off. So I'm going to say force it into the material by minus 20 thou there. Don't forget to update your RPM and feed rate. It gives you a warning there on that tool. That's okay. And again, we'll go to top view, makes it a little easier to see. And I want to start on this cavity first, so I'm going to choose the outside and climb mill. Click on do it. That does that one just fine. Let's do the other one. This direction, it'll be climb mill. We'll just start there, which is fine. Click on do it. So that looks pretty good. Those are all, let me open that up. 150 down, that's good. Now we need to do the outside as well. So let's just choose this side and click on do it. So now we have our chamfers done. Let's do a little rendering on that. Slow that down. So there's our first cut. Second cut. And third cut. If we zoom it up a little bit, you can see it does have a chamfer on there. All right, next we need to spot drill. So let's just choose an empty tile here. I'll just click in space to deselect everything, and I'm going to clear this out and replace this process with a drilling process or hole process, along with that spot drill. Okay, since this is spot drilling, we're just going to feed in, wrap it out. Again, we're going to stay at 1/4 inch there. The top of the material we're cutting is 0. Now, if you look at the print, remember it says 20 thou chamfer on all edges and holes. So these are 3/16 holes, so I'm going to start with that. So I'm going to type in 0.1875. And remember, it needs to have a 20 thou chamfer, so that means we have to add 40 thou. So by typing in 0.2275, you can see this little diameter symbol. You're telling Gibbs that you want this spot drill to cut a 227.5 thou diameter chamfer. And of course, put in your RPM feed rate. You can click on the points, hold the control key down. Gibbs doesn't care whether you use points or circles, doesn't matter. They don't care. We're not going to do this one because this requires a little bit deeper. And click on do it, and you'll see there's our holes there, 6 holes. Now we're going to still do this with the same drill and everything. We just need to change the depth. So I'm going to click in space to deselect these holes here and open up this process. And this time I need to type in 0.375 plus 0.040. That means we want that spot drill to cut a 415 thousandths diameter chamfer in there. And just click on that single one by itself. Click on do it. Now we have our spot drills, so let's watch that. There's our 6 holes there and the 3/8 hole. All right, now we're ready to put a drill to this, so we'll still do a drilling process, but just change tools. So take tool number 6, drag it, put it on top of there. Going to bring up this process here. I don't want to feed in and wrap it out unless you which is a 3/16 drill. Unless you have high pressure coolant, then you just blow through the hole and back up out because it blows the chips out. But we're going to peck on these, so we're going to do a peck full out, and of course adjust your RPM and feed rate and your clearance. That means when we come back into the hole, we're going to stay 10 thousandths away from where it starts cutting. And how much of a peck do you want to do? I'm going to say 200 thou. Top of the material is 0, and I don't care about the point so much, but I want to make sure the full diameter, you can see this line going over to the edge of that tool. I want to make sure the diameter goes to minus 1.0, we'll say 50, so it'll be 50 thou below the bottom of our part, and everything there looks good. So again, we'll click on the points or the circles, either one, doesn't really matter, and click on do it. Now we have our holes done there for the 3/8. While we're at it, we might as well, this is the 3/16. While we're at it, we might as well do the 3/8. So just take the 3/8, drag it down on top of there. Adjust your RPM and feed rate. And again, minus 1.050. Again, just choose this hole. Make sure you don't choose the other holes. Otherwise, it's going to drill 3/8 hole in all of them. And do it. Let's take a look. See what we have. So there's our 3/16. And then switch tools to a 3/8. So there we have our part finished. We can bring in our vise here. This gets into a little bit of solid modeling, but this will kind of introduce you to a little bit of solids in here. But our part looks pretty good. Let's bring in the solids and then we'll post some code. Let's save what we've done. And let's bring in our vise. So usually when I'm working with solids and bringing them in, let's turn off our cam and tools so we don't accidentally delete something. Let's just go to File and Import and go to your folder that you've downloaded everything that was off the website, and make sure you choose this Kurt Vise as a parasolid X_T, so make sure you select that. And then it'll show you this vise. It'll say D675 simplified. Just click on that and click on open. It's going to take a second to bring it in. And you can see it comes in. It's all nice and yellow there. We'll just click in space to deselect it. And when you bring in fixtures in Gibbs, it matches the origin on the fixture to the origin of your part. So you can see when I created this vise, I put the origin on the top left corner there. So that's why it matched up to my part there. Now you can see my parts inside the vise, which we don't really want, but that's okay. We'll fix that. So first we need to, in the solids, we need to make sure face selection is off. And you can see I have the vise here, just the whole vise all is one solid, and the rear jaws is one solid. So I'm going to click on here first, hold the control, select the other solid. And while you have it highlighted yellow, just right click anywhere on the yellow. And you want to go down to show properties of selected. That means it's going to show you the properties of both these pieces, as you can see up here. And we want to change it to fixture display only. Don't do fixture display only. And cord height, usually I put in 10,000 just to reduce our file size. Click apply to all. Now when you click in space, you'll see that is red. So Gibbs knows that's a fixture now. Now if I was to do rendering, you're going to see it's not going to look so good. So let's just play it. And you're going to see the tool cut into the jaws. Doesn't look so good. Okay, because we haven't moved our vise where we want it. Now, so let's, best thing to do is let's just go to top view first. Now we kind of want to center the part on the vise. We know the jaws are normally about 6 inches on the Kurt Vises, so let's just select our part again, hold control, select the rear jaw, and we're just going to do just like we would do in geometry, go to modify and translate. So we're just going to translate that vise. We know our part's 4 3/4. This is about 6 inch. I'm just going to move it to, we'll just say -1 there. And we'll see if that looks okay. Now you can see I moved it a little too far. That's okay. Let's move it back about 1/4 inch. And it looks a lot better. Maybe another 1/8 of an inch. That looks a lot better. Now if you want, you can extract the geometry, and that's mainly in another class. You can extract the geometry off this vise to put it exactly where it's going to be on your machine and exactly where your part's going to be, especially if you put a jaw stop on here to put the stock against that. So that's mainly in another class. So let's go to a side view on here so we can see the side, and you can see the vise is okay on the stock here, but we need to go down with the vise. So let's just select the vise. And again, let's do the translate, but we need to move it down at least 1 inch. But remember, our end mills went down -1.050, so I got to go past that. So I'm going to say move it -1.1. So that's going to move the vise down 1.1 inches. And now, without measuring this, I don't know how far to move this jaw, probably pretty much about 3/4 of an inch. Like I say, again, you can measure the jaw and move it all over and move it down. If you're working with solids, then you could just automatically have it do that already, but we're just going to guess on this part just to get it going, so we're not really working with solids altogether. So again, I'm going to translate that. Let's zero that. Let's do -0.75. Okay, that's probably perfect on there. Like I say, you can measure it and get it absolutely perfect, but I think that's good enough for now. All right, let's do the rendering. And I think everything should be good. We'll run it all the way through here so you can see it from start to finish. And now you can see the part is finished. We didn't run into the vise. Everything looks pretty good there. Now the last thing we need to do is probably, well, one thing I would do before I close it, or post code, is you want to save it right here. So just click on save. And what that does as well is take a snapshot of this, so when you go to open the file again, it'll have a preview of this snapshot before you open it, so you can kind of have a preview before you actually open the file just to see what you're going to be working on or modifying. So now let's close the rendering and let's post some code. So let's click on this icon here, post processing, and choose the machine. In this case I just chose the Haas machine. If you click on here, this will give you a list of the post processors that you have purchased. So just load one of those up, whatever machine you're going to create this for. And then of course click on this icon here. This is asking you where do you want to actually save this file. So choose whatever folder you want to save it in. Then from here we go to the actual posting of the code. What's your starting program number? I'm just going to say 100. So you probably want to choose a number that's not already in your machine so you don't override it. Normally I go sequence from 10 to 10. This is like N10, N20, N30. This leaves you space in there if you need to put an N number inside your program at your machine or whatever, and put a comment or whatever you like to do. So I like to at least spread them out a little bit here. We're going to post in inches. We want to insert comments, insert optional stops at tool changes, and then work fixtures. Normally this is just a 3-axis mill, so I want every operation to be at G54, so that's kind of the default there. If you want a different one, you can choose drop down menu, choose whichever you'd like, and you can make them all by the same thing by clicking on here. Nothing on special info. So then just click on process. It's going to process your post processor using your post processor and give you the code here. So you can see this gives you the information for your machine. The tool list is right here. And here's our code here. Now every post is a little bit different depending on what the machine is and depending on how that customer wants to use the post, how he wants to go home, if he wants the G49 in there or not. I personally like the G91 G28Z0, but that's up to you. This is a customer that likes it this way. But as you can see, here's your roughing operation, or actually facing roughing operation. And you'll see this is a volume mill, and you won't see any G0s in the code. Doesn't need them. You can quickly click down to the program just by double clicking on each of the operations. You can see we use canned cycles for everything. This makes it programming a lot faster. So now you have your code on your machine and you're ready to go. And this should be everything you need to start your first project. If you can successfully draw this and cam it, then you're at a good place to start getting more and more advanced parts. But this will give you a good idea on how to at least start programming with Gibbs and have successful code and successful output code and make your parts. So thank you very much for watching.